My name is Rehan. Today I am going to discuss software development testing and its two techniques, unit testing and integration testing. So before we start, you can see on the bottom right side of the screen, there is a QR code is given and a pin code is given. So you can play Kahoot game using this information. And there are a few questions you have to answer. So this is the list of topics we are going to cover today and their respective slide numbers. You can click on the slide and you can directly open it. Three learning outcomes we are going to cover today. So by the end of this lesson, you will be able to understand the fundamental concepts of software testing, what are different testing techniques, and how we apply those techniques. So software testing is basically a process through which we find errors and bugs in the software before it is delivered to the client or the end user. The main purpose of software testing is to find errors, to comply with the requirements, to evaluate its performance, and to evaluate its quality. Software testing is performed or it is conducted by developers and independent testers. Developers do it during the development when they are writing the code, and independent testers, so they do it independently when the code is ready or it is in the QA for testing. There are different types of testings: manual testing and automation testing. Automation testing is done using different tools, while manual testing is done by writing test cases and other methods manually by the developer and the software testers. So manual testing has three techniques: white box testing, black box testing, and gray box testing. Gray box is a combination of white and black. So mainly these white and black are used. White box testing, it is performed by the developer. The developer checks the logic of the software of the program and test programming structures like loops, conditional statements, algorithms through white box testing. He basically tests the code. In black box testing, functionality and overall requirements of the software, they are tested. So it could be functional, it could be non-functional. So in functional testing, we perform different tests like unit testing, integration testing, and system testing. But today we are going to cover only unit testing and integration testing, and two types of integration testing, top-down and bottom-up. Before we start testing, we need to understand the level of testing, how we perform it. So first of all, when we are developing, at developer level, we perform unit test. That is level 1 test. We develop one component, test it. Next, when that component is developed, we integrate that component with another component and then test it. That is called integration testing. We perform at level 2. We keep integrating components and keep testing. When all those components have been integrated, then we perform test for the entire system at level 3. And finally, we test the whole system and check its acceptance. There is also need to understand a few concepts which are very much relevant to the software testing. First one is a module. When we say module, what do we mean by module? Okay, module is a relevant term that we use sometime for the units, sometime for the components. Components mean those, you can say modules or assembly of components that can be added, removed, or replaced in the system. And we use these terminologies interchangeably. We say hardware modules, I have memory modules, RAM is a hardware module. If I talk about modules in a software system, software application, for example, ERP, I say supply chain management, human resource, finance, these are the modules. So module is a relevant term. I sometimes use it for the units, sometimes I use it for the components, sometimes for hardware, sometimes for software. Similarly, an important concept is stub and driver. Stub and driver, they are dummy programs that we write to test a main module. For example, this is my main module. I want to test it. To test this main module, upper level module is not ready. It is not yet developed. what I would do, I will replace this upper level original module with a dummy module to test main module. This is called driver. Similarly, if I want to test this main module and I need a sub module, lower level module, but this lower level module is not ready, it is not yet developed, then what I would do, I will replace this lower level module with a dummy module. That lower level dummy module is called stub. Both driver, stub and driver, they are not complete programs. They are used only to make the data communication with the module which we are going to test. Stub are called programs, while drivers are called calling programs. Here we can simulate this one. You can see in this example, we want to test this module. We need higher module. Higher module is not ready. What we do? We replace that higher module with a dummy module. That is a driver module. Likewise, we want to test this module with lower level modules. But these lower level modules, they are not available. They are not yet developed. What to do? We replace these lower level modules with dummy modules. Those are called stubs. This is how we implement stub and driver modules or functions when we test any software. So first type of testing is unit testing. Unit testing also use stub and drivers. A software engineer or a developer performs unit testing. Okay, he tests one unit that he has developed, write test cases and perform the testing and find the results. Those units of source code that are tested under unit testing are like functions, classes, objects, methods, and procedures. One unit at a time, one function, one class, one object. How they are performed? Similarly, I want to test this unit, this function. So I will define driver modules. If upper level module is not available, I will create stub modules if lower level modules are not available. So I use this driver and stub modules and I will test my main module and its functionality, if it is working fine or not. And then I will publish my results. Here is an example. We have 4 modules, A, B, C, and D. A is login page, B is home page, C is print setup, and D is logout page. All these pages are interdependent to each other. Here is first scenario. I want to test module A, but module B is not yet developed. It means I want to log in. After login, my control should go to the home page. But home page is not ready. How would I test the functionality of login page? The solution is very simple. I create a dummy page, home page. That will be the stub, and then I can test interaction and functionality of these 2 pages. Similarly, there is a question for you. I want to test module D. When I log out, then control should go back to the login page. How can I test this module D logout functionality if login page is yet not developed? It is not ready. Can you answer? Any one of you, please go ahead. Okay, so if you see the solution for login page, we create a dummy page. That will be the stub. Very simple solution. So this is how we add drivers and stubs, and mainly stubs in the unit testing to replace our those modules which are not ready yet. Similarly, in integration testing, which is second important testing approach, we integrate different components and then test them. In unit testing, we test one component at a time, but in integration testing, we integrate 2 components and then test. Integrate 3rd component and then test. Integrate 4th component and then test. That is called integration testing. There are two methods used. First one is Big Bang and second is incremental approach. Big Bang says that we test multiple modules together, and sometimes we combine multiple modules together and then test. But most commonly used technique in integration testing is the incremental approach. Incremental approach has three types: top down, bottom up, and sandwich. Let's take one case. We have this module hierarchy. It has three levels: level 1, level 2, and level 3. And we have 7 modules: A, B, C, D up to G. Now we want to integrate. First of all, we integrate A and B. C and D are not available. They are not ready. We define stubs. Step 2, we already integrated A and B. Now we integrate D. C is still not ready. Okay, so for C, what we do? We use stub. Here is an interesting thing you should ask from me, that why we integrate B and D first? Why not C first? So normally we prefer that we integrate terminal modules first, because terminal modules, they do not have submodules, easy to integrate. C has submodules. That's why we do it in the end, to avoid complexity. So here you can see, now we integrate A, B, D, and lastly we integrate C. But C, all these submodules, they are not available. We add stubs. Similarly, we integrate E and we use stubs for F and G. And lastly, we integrate EF both and only stub for module G. This is top down, level 1, then level 2, then level 3. And where modules are not available, we introduce stubs and keep integrating, keep testing. Similarly, in bottom-up approach, we start from level 2. We integrate this one because main module, upper level module is not available. We use driver. Driver and step both are same thing. They are both dummy programs. But if we introduce them at upper level, they are called driver. If we introduce them at lower level, they are called stub. So this level we integrate, then this level we integrate, and this level. Keep adding drivers and keep integrating. This is bottom up, starting from the lower level going to the upper level. And last approach in this one is sandwich approach. Sandwich approach is the hybrid approach. Partly we do top down, partly we do bottom up. There is a humor, like 2 unit test, they are successful. But when we integrate both units, the test is failed. Together, they are not working. Right? So you can see in this picture. So what is happening? Software quality assurance team or tester, they say this is the problem by the developer. Developers say, no, I have already tested. There is no issue. They do not agree sometimes. What is the solution? Better we go for automation. We use different tools for testing. Are so many tools available for web application testing, mobile application testing, both for Android and iOS platforms. These tools help you to write test cases, stub, driver, unit testing, integration testing, and execute them. They save the time, testing is fast, and results are better. So this kind of disagreement is avoided. Here is a research paper. You can see this research paper, mobile application testing tools. In this research paper, here on this link, you can get this research paper, and I have downloaded it for you also. And in this research paper, the authors, they have discussed different testing tools to test mobile applications. In this research, they found that functional testing, performance testing, and usability testing are the top testing techniques which are used to test the functionality of any software. They have introduced different tools like APM, Robotium, KIF, Salendroid, Monkey Talk, and they have explained that which tool is suitable for iOS, which tool is suitable for Android, and which is for all. And in this table, you can see here, they have summarized benefits and disadvantages of all these tools and which platform they are suitable for. And all these tools, they are open source. There is no license fee. You can use them freely. And mostly software testing teams, they use these tools. Similarly, in this research paper, they have found that integration testing and regression testing, these are the two challenging testing techniques because of the stub, integration, and driver functions that we introduce to the testing. So that makes these testing techniques complex. But we have to do those testing techniques. But if we use these tools, so these testing techniques, they become testing become quite easy. So you can perform it. Okay, so with that, here we comes to the conclusion. So today we discussed that testing is used for finding errors to ensure the quality of the software before it is delivered to the client. We have different testing techniques, unit testing, integration testing, and these techniques use stub and driver dummy functions to test the functionality. Unit testing is performed for one unit at a time, and integration testing when we integrate combined units and then we test it. And this testing can be done manually, plus you can use different tools to test these functions, functionality, code in your software. With all, so that's all for today. Thank you very much. If you have any question, you can ask. Yes, don't forget to play Kahoot. It's already on, so you can play it today. All right. So thank you very much for your time and see you in the next class.